Okay, so we'll get into dial gauges this week. First, we're gonna learn the parts of the dial gauge and then applications. Then we'll get into how to zero the dial gauge, how to measure object heights, and then we're gonna do our usual thing using your gauge block to measure the heights. Of course, the instrument for this lab is dial gauge. We also call the dial gauges as the dial indicators, okay, the same thing. We use them to measure the vertical height. And we measure the alignment, okay, of one surface respect to another surface. And I'm going to show you how to rate it. So we have plunger, and of course in the dial gauge we push, okay, in a plunger, and we read how far that plunger has moved on the dial face. So this is how this instrument works. Of course right now you wouldn't understand it, but as we go into this lecture, you can be able to see some diagrams, yeah? And of course in the lab you can be able to use it. So this is the first application. Of course we use a dial gauge for alignment of one surface to another. So here you can see a motor shaft and then your pump shaft. We're going to use this dial indicator to align this motor shaft to the pump, okay, shaft. So first we're going to clamp this dial indicator to the motor shaft. Then we're going to rotate the motor shaft very slowly. And you can see in the instrument the dial indicator pointer is going to rise and then it's going to fall, depending on this center, okay, line of that motor and of this pump. If they're not on the same level, your dial indicator is going to rise and fall, right, in this dial surface. So this is how we align two surfaces, okay? So we don't want a lot of rise and fall, we want to stabilize, yeah, this pointer, so we can be able to understand that these two shafts are in alignment. And this is just a little bit better picture for you, so you can see how we use the dial indicator to align the surfaces. Okay, and here is the rotation of the motor and the pump, so you can be able to see how we're using this instrument to align the two shafts. In this picture, you can be able to see the table saws, and they have slots machined into the tabletop to guide the wood through that blade. Okay, so here is the blade. So we're going to use this dial indicator to align the saw blade, okay, to the guide slots. So if this blade is not parallel, right, to the slot, then the wood is going to be pulled sideways and it's not going to be cut straight. Okay, so we're aligning the saw and then the slot machine. And then because we use a jig below to clamp this dial indicator, and then that jig is then slide along the slot machine in the tabletop. So if the saw blade is not parallel to the slot, then the dial gauge reading is going to change because the jig is moved along the slot. Okay. And of course, I'm going to go ahead and pull a video of the saw blade to cut the wood using the slot machines, and this is how it goes. Okay. And of course, here is trying to show you how we put the dial indicator to be able to check the alignment, okay, because it's very important in cutting. The next application that we use for this instrument gauge is that we use to check the misalignment. How do we do it? In this example, we're gonna clamp, right, the dial indicators to the motor shaft like this. And as this motor shaft is rotated slowly, the dial indicator pointer, which is this guy here, yeah, will rise and fall if that center, this line, if they're not parallel to each other. Yeah, here is a completely misaligned. And this is how we check the misalignment by using dial indicator. Our next one is measurement. Of course, we use this instrument to measure, so that's another application. And here you can see the bridge jig is holding this dial gauge over the cylinder, okay, bore, and then of course contacts the piston. So as we turn the crankshaft, okay, by hand, what we do is this dial gauge is going to measure the total travel and the peak height, okay, of that piston relative to the height of that cylinder block. Of course, in this diagram, it's a little bit difficult for you to be able to see, but don't worry about it, okay? And if you can be able to take right now at this moment, that this, look at this dial indicator, okay? This is where you're gonna touch, right? And be able to sense the height, all right, of anything or any object that you're trying to measure, yeah? So this is very important. And then the pointer inside of the dial is also very important. The pointer, of course, is going to show you, okay, the value of the height. And of course, we have two scales right here, the big one and then the little small one right in there, okay? So if you notice that, you're kind of okay for now. Right now, oh yeah, we use this instrument gauge in applications, you know, like alignment and checking the misalignment and measurement, then you're okay. Yeah. So here, when you look at this, so here is the cylindrical part. Okay. This part is rotated, and that's why you can see here, right? Your part is colored brown here in this diagram, and the dial gauge here is going to change if the part is not round or if it is bold. Okay. So I fixed this, and so anyway, so the fixture, of course, holding this dial indicator, okay, it can be slid along the flat. I wanted to say like it can slide along, but it's okay, okay. In passive mode here, so it can be slid along the flat surface plate to measure at different points along that cylinder. Meaning like it can go, yeah, from here it moves along this cylinder surface. So this is how we hold the dial indicator. So this, all right, the contact can be able to slide along this cylindrical part. Okay, of course the cylindrical part is also held by this fixture, yeah. And this is, of course, is your surface. And here the center line, see that is really very important for getting the right reading in the dial indicator. The next thing that we use for the dial indicator is in quality assurance check. So here in this diagram, it just is showing you, you know, how we check the ran out and the volt in this part. Okay, see like how we hold the dial indicator like this and put the part, and then of course these blocks are holding that part, so you can be able to slide this dial indicator along and do what you need to check, okay, in that part. So in this example, as we're checking the ran out and volt. Here in this picture, we're showing you the mounting base of a dial gauge, and you can see here is a dial gauge and it is held by this, okay, stand, and here is the mounting base. And of course we call this a magnetic mounting base for this dial gauge. Well, it is magnetic because it has a powerful magnet, and it can of course hold tightly to ferromagnetic material surfaces, okay? So we can be able to hold the gauge in place. If your base is is not very good, and then you're not going to get accurate reading in your dial indicator. Okay. Of course, in here, this arrangement right here, you have your arms and the clamps, right? Altogether, they are holding this dial gauge. Of course, you can be able to adjust the dial gauge to the surface to be measured. Yeah. I threw a YouTube video here for you to be able to see the dial indicator. And of course, I am going to run it just a little bit. Yeah, you can use this link at your home when you do this, when you take this lecture, and watch the full video of it, so you get a little bit of familiar. You can familiarize with this dial gauge before you get into your lab. Okay, so this is what a dial indicator looks like, and here is the base that I just show you. Okay, and you can see the magnetic base right there. And of course, this is just a setup, so it can't be exactly the same as the one that we just showed you in the previous slide. Okay, this is a little bit different, but you can watch this a video and familiarize yourself with this instrument before you come into the lab. Okay, so I am going to go ahead and stop right here for this video. You can watch it. It's about like 20 minutes. Okay, since we have a very limited time for lecture and also the exercises, it's really difficult for us to be able to run the whole video for you. Okay, all right. So here in this lab, we're going to study 3 types of dial gauges. You gotta know how to read, and you have to know how to use the dial gauges, and you have to know how to read these markings on them. The discrimination, you know that. And the trouble is just sliding, okay, sliding the indicator up and down. Of course, you will definitely look your reading in your dial indicator, okay, which is your dial face, because the reading, the scales are inside of it. And if you have noticed, we have 2 different scales in there. One big, right, going in a counterclockwise, and the other one going in a different direction in a clockwise direction. Okay, so you have a clockwise direction for the big dial, and then you have a little counterclockwise direction for the little dial. And we're gonna, of course, observe, right, all these dials and read our readings. So we'll carefully look for the marks. That's going to tell you the graduations, what they are. And you have to, of course, understand what each mark on the dial means. So after looking for the marks, which is going to tell you the graduations, and we observe the mark on the dial, and we are going to determine the full travel of each, okay? Each one of them. Travel means the pointer is traveling inside of the dial. Okay, and I'll of course show you the picture so you can be able to understand what we're doing. Okay, so right now, just try to know the 3 types of dial gauges, okay, in this lab. So we have inch. This is a 2-inch dial gauges, right? But they have a different, of course, markings and scales. So when you take a look at it, this is 0.001 to 1 inches, and this one is 0.25 to 0.0005 inches. Okay, and then of course we have our metric. So here are your 3 types of dial gauges. So when we talk about the full travel, right, the term the full travel is just a common word. It is telling you that it's going like 1 full inch, okay? And if you pay attention, you're going to see how different this 2 is. See? So here, look at that. You have a big scale here, and it's a little tiny scale here, yeah? Going clockwise and a counterclockwise. So anyway, so when you take a look at it, you're going to see this little, scale right there, and we call that a turns counter, okay? So this inch, dial gauge has a turns counter. This one doesn't. See, there's a no little dial inside of the big dial right here. Yeah, so that's the difference between this inch dial gauge and that inch dial gauge. So we call it, this is an inch dial gauge with turns counter, and this one is inch dial gauge without turns counter. Okay. Alright, when you carefully look at this metric example here, so your metric dial gauge, look at this, you have a turns counter. When you take a look at the measurement, you're going to see, not the measurement, I mean the scale, you're going to see 0.01 millimeter all the way to 10 millimeters here. So this gauge has a turns counter. So that's this little dial right here inside of a big dial. Alright, then we'll get into the parts on the dial gauge. So when you take a look at it, so let's start from the bottom. Here this is called contact, and here is the stem, and here is your shank. And then of course this entire thing, the round where your scales are inside is called a dial. And of course you have a turn counter, this little dial right here. It's going to keep track of how many times the main pointer has gone around. It means that it's traveling, 0 and then back to 0, another back to 0. So it's going to keep track of that. So not all dial gauges have a turn counter, and I've already shown you 3 times, right? And you have an inch, okay, with the turns counter. You have a metric with the turns counter, and you have an inch dial gauge without the turns counter, and you also have a metric, okay, or dial gauge without the turns counter. So anyway, then we'll go into the dial, and you can see this. Look at this little arm right here, and that's your pointer, okay, and your bezel. So your bezel is rotate. It's going to rotate to set 0, and this is going to rotate, okay, the numbers on the face. Of course, if you look at it on this two-dimensional drawing, you can't really see the bezel, but it's right there. See the rim right here? And then of course, so this is your movable markers for setting, okay, for setting past your fill limits right here. And this is your movable counter. They're all moving, by the way, and it's very sensitive. Your contact is sensitive, your bezel is sensitive, your pointer, of course, is also sensitive, because this movement depends on the touch between this contact and the surface that you are measuring. Okay, and then we're going to flip it, and you can be able to see this bracket in the hole, and we use it in order for us to be able to hold this dial indicator on the setup arrangement or the stand, okay, the one that I show you with the magnetic base stand. So that's where we're going to fix this, all right, bracket and hole into, so we can hold this dial indicator up, and we can be able to study the surfaces, right, and height with this contact. Of course, this tip is removable, because you can remove this anvil, and you can also replace this anvil with different type. It depends on what you're measuring. Of course, when you look at the stem, you can be able to take it out, and then you can be able to put different stem, right, different extension to the stem. Okay, so let's see mounting. Okay, mounting. So when you look at this, you can see this magnetic base right here is pretty heavy, and of course it's necessary because it's very strong in order for you to be able to hold this dial gauge, okay, in a very unstable way. So here you can see the screw, and that screw we use it for mounting the dial gauge, okay. It's pretty easy, you just unscrew it and it's going to move up and down. Of course, these are again the screws, and we use them to adjust the height of that dial gauge on that stand. So here is your stand, and you can see this dial gauge, okay, we can mount it on this stand. So of course, this is a vertical stand that we use to measure the height, okay, of the parts that you want to study. This is just a wrench, okay, or we call it the T-wrench or hex T-wrench. You can also use, of course, other two that can fit into here to mount that dial gauge, okay, firmly onto this stand. If you have already used the dial gauge, then you shouldn't have any kind of issue in your lab. But if this is your first time, then these diagrams is going to help you, so you know how to you know how to set the dial gauge on a stand without any issue in your lab. Then we're gonna bring in our square, you know, because we want to make sure the gauge is mounted perpendicularly right here to the stand base. Yeah, so here you can see the 90-degree. When we say perpendicular, we're talking about, okay, so I'm just gonna go ahead and draw this. So this got to be 90-degree. Okay, my drawing is not very skilled, but it's okay. You can you understand that this is a 90-degree, okay, angle. Okay. Okay, now let's see how we do the measurement. Okay, after we set, right, the dial gauge on this stand, we're gonna measure, yeah, something. So here in this example, we have gauges right here, yeah, your gauge blocks, so 1, 2, and 3 stack here, and we need to measure the height of this, yeah, height of this stack. So I have 3 blocks in this stack, of course. And let's see how to measure the height of these objects, yeah. And of course, you have to pay attention for your measurement compliance and also your specification, yeah, in real world. Okay, so how are we going to measure it? Right now, of course, the object that you're interested to measure is this dowel, yeah. So your dowel is already, I've already taught you what a dowel is, which is your cylindrical, okay, rod right here. Yeah? Of course, in lab, your previous lab, you're using little tiny and the 4 little dowels inside of a bag, but we also have a dowel like this, okay, which is a bigger one. Of course, in this example, you want to, you want to measure, of course, the height of all 1,000 round steel dowels. That's a lot of, yeah, and you have to determine if they are in their specification. Yeah, so of course, the measurement usually quality team is going to do a lot of that. Of course, that's what is, you know, these instruments are for, to check. So anyway, so first we're gonna stack, of course, our gauge blocks, yeah, in this example here, and you're gonna have a specific height here, depends on how many blocks you've got. Yeah, we do it all the time, every lab. And then we're gonna do zeroing out of this dial gauge, yeah, which is you would zero the gauge right here on the stack of the gauge blocks right here. Yeah, so you're gonna see how to do this on the other slide. So you'll definitely record your zero reading because your gauge is not typically okay, zeroed on true zero. So this is your zero right here with a pointer, okay? So this is where we're doing zeroing this reading. Okay, so when you read it, a foreign student gonna have some issue here. I just trying to tell you that you have to zero out, you know, because the gauge is not set for zero. So what you have to do is you're gonna have to use a plunger, yeah, to push push in somewhat so we can measure the items larger and smaller than your specification. So this is kind of bulky in writing, okay, but in reality it is we're just setting right the gauge, and then we are going to make sure that this little tiny pointer is at 0, okay, and of course we're going to play with the plunger in order for us to be able to get the pointer to the 0, okay, mark on this dial. Then of course we're going to remove the gauge block like we always do, and then we're going to insert the object, okay, of interest to be measured, and then we're going to see how much the dial gauge moved or traveled, and whether it has moved or traveled in a positive or negative direction, okay. Okay, so how are we going to set onto 0? So we're going to use the height adjusting screw, okay, here. So we can see this little screw here. I'm going to adjust the height of the gauge so that the dial is going to point to 0 right here. Yeah. So the adjusting screw is very important to set the pointer to 0. Since we push right our plunger intentionally in, what happened is that the pointer is going to went around, right? One full turn or 2 or 3, okay, full turns to get to the 0, yeah? And that is quite normal. And why do we have to do that is because by doing that we can be able to measure the larger, okay, we can be able to measure larger than the specification, and also we can be able to measure the items smaller than the specification, yeah? So we play with the plunger, and then of course we play with adjusting screw to set the pointer to 0, yeah? If you deliberately cause the plunger to be pushed in, then the pointer is going to go around 1, 2, 3 turns, right? And that's okay because we do it, yeah, in order for us to be able to measure the items larger than our specification, or sometimes smaller than our specification, okay? But in the lab, you're gonna see when you do it, okay, and how this dial is gonna go around to measure it. So the point is, we don't really set the gauge to true 0, okay? So if you set to true 0 without turning, yeah, 1, 2, 3 turns, then we cannot be able to, or we would not be able to measure the item smaller than the specification because the gauge cannot go to negative, okay? It's just an instrument thing. I can show you here because the instrument is not in your hand, but when you are in the lab, right, and I'm going to show you, and you can be able to understand why we do the plunger in, right, method, just so that we can be able to use the dial gauge to measure the item smaller than our specification. Of course, this example dial gauge has no turns counter on it, so we have to watch carefully as we bring the gauge slowly down on the gauge blocks. And of course, I keep bringing it down slowly until the pointer, right, has gone around either 1, 2, 3 turns, and then keep track of how many turns it went around when we brought it down. After we get this contact, all right, on the surface of our gauge stack here, then we're going to tighten all the screws. Okay, when we do the mounting, okay, just going back to after, of course, measurement, we just want to make sure that you understand how to do the mounting. Is first we clean the base of that stand with solvent in the lab, right? And then you're going to make sure that your plunger or your stem here, yeah, of your dial gauge is mounted as perfectly vertical as possible. And of course, we're going to use a square to get our 90-degree stand, okay? And you're going to tighten the mounting screw with your hex, okay, T-wrench. And then you're going to raise the gauge away from the base of the stand, okay? And then raise the gauge away from the base of the stand up, and then select the clean, all right, your gauge blocks, and then ring them all together so they're gonna perfectly stuck to each other to the specific height. And these are your reference, all right, for measuring parts. I would say like this mounting should come before the measurement, but I don't know why they're putting it here, okay? Okay, so after mounting, you're going to bring the dial gauge down on the gauge blocks until your dial has gone around 1, 2, or 3 times, right? As you bring it down, it's going to go around, and then your pointer is pointing close to your vertical upward. Then we are going to loosen, right? Your bezel, of course, the bezel is right here, lock. If you have the bezel lock, loosen it so you can be able to rotate your bezel, right, until your 0 and the pointer is going to align perfectly to each other. So this is how we adjust, yeah, the pointer to 0. And then we're going to tighten the bezel lock back again, and then we're going to recheck the 0 is there with the pointer. And then you're going to write down the reading of that small dial, okay? If it has one, and if you don't have a small dial, all right, like here in this example, you're going to write down how many turns, right, the pointer went around when you zero it, okay, when you bring this down and zero it. So it's not that complicated, yeah? So you're going to set it, mount it, and then you're gonna prepare your object height, yeah, and then you're gonna bring this down. As you bring it down, you're gonna observe, yeah, how many turns this pointer go, and then you're gonna use your bezel, yes, and make sure that the pointer is at 0, yeah, and then of course you have to write down how many turns it went around before this contact touches the surface of this, in this example, the gauge block stack, yeah. So here's a diagram showing you that the gauge, okay, is brought down onto the gauge blocks. Your die gauge is block, okay, brought down onto this gauge block, right? The surface right here, and then of course your pointer, okay, as you bring it down, you're gonna watch this die, and it's gonna go 1 round, 2 round, 3 round. In this example, it went on 3 rounds, okay, and it's gonna come back. Your pointer, after it went 3 rounds, it's going to come back towards the 0, yeah. So of course the pointer is not exactly vertical at this point of time. So when you take a look at this die in a bigger picture, you can see that the pointer is not yet back to 0, yeah. That means that we haven't used a bezel to align the 0 with the pointer, yeah. Okay, now we get to the next diagram, and here we have already adjusted the bezel, yeah. We rotated the bezel, and it is, okay, so this black bezels, okay, been rotated, and you can be able to see this pointer is now in alignment with that 0. They're not exactly vertical, but they're very close, all right, in alignment with the 0 and the pointer. And that is pretty good enough. Alright, this is a different dial, because you can see there's a little, right, dial, which is your turns counter. And this is of course your inch, yeah. So when you look at this, you can see a 1 inch, so therefore this is an inch gauge, and it has a turns counter. And of course our purpose is to get the pointer in 0 alignment. In this example, we brought this dial, yeah, die indicator down to the gauge block, and it turned, right, two times for this die gauge. So it turns, all right, 2 times, so it means that you've got about 0.2, so that means it went 1 time and then it went 2 times, okay. Because 1, right, a complete round is a 0.1 inch, okay. So if it went like a 2, yeah, complete turns, you will have like a 0.2 inches, all right. So that's what is talking about. Don't get confusion of this range. This is just telling you, the smallest one is going to be 0.001, and when you count it all together, it's going to give you 0.1, all right, for 1. For the entire, right, big or dial, and you're gonna have a 1 inch in the side, yeah. So let's go like a 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 7, all the way back to 0, okay. And of course here we have a turns counter, so you have like a 1 turn and then 2 turn, and that's a 0.2, okay. So if you have like from here to here is 0.1, you're gonna have like a 0.1, okay, inch. So 1 turn in a little dial right here is going to give you 0.1 inches, right? And in a larger dial, you're going to see, yeah, so 1 complete little dial is equal to 0 to 10 here, yeah. So that's a point, okay, going all the way down. So that's a 0.001, right, for each one of them. This one is a metric, all right, a gauge. So in metric gauge, die gauge, when you look at it, you can see a little turns counter here, which is your little dial right here, okay? And of course, it's going from a 0.01 millimeter to a 10 millimeter. So here is a little bit better than the previous example, okay? Because here, like, you can't really see in the inch, okay? You can only see like not very clear, right, for this pointer. But in metric it's a little bit easier, because you can be able to see the turns very clearly. Yeah, see? So now look at this little pointer right here, it's showing a 3. It means that, okay, we went around 3 times. So we, the plunger, right, currently push in at 3 millimeter. You're gonna have a little bit of a difficulty getting the term, right? Technical term, and that is 3 millimeter, and then we call it the plunger, right? As pushing to 3 millimeter. So don't feel bad about this technical term, right? It's just telling you that the contact with the surface is adjusting, and this dial, right, is very sensitive to that contact to the surface, all right? So therefore it is going around in order for us to find the balance. Yeah, so the pointer rise and fall, meaning that this dial indicator is trying to balance, all right, itself. So here are 3, right? This is the hand of former professor. Okay, we're very grateful to have these videos that he made, so I don't have to make it for you for the semester. Yeah? And I have put them up on YouTube, and you can be able to get the links out of it, and you can run it, all right, at your home. Of course, I'm going to go ahead and show you. The very first one is how we play with this plunger. Okay, so here see how it is rotating both of them. The big one is going clockwise, and the little one right here, see, is going counterclockwise, and you can be able to see how many turns it went. Okay, in this example, see? Yes. Alright, the next one is how we use this gauge block, and we're going to bring this down, right? As we bring this down, look at this, right? The dial is going to start going as soon as our contact touches the surface of this gauge block. See that? And as you do it, you have to make sure that you pay attention, okay? How many turns it went in this little, all right, dial, of course. And then we're going to adjust the screw right here so that we can be able to set, all right, the pointer and the 0, okay? Okay, then we come here into the measurement, right? And we are going to, after adjusting the 0, we do the measurement, okay? We will push this gauge block out, and we're going to bring our dial right there because we want to measure the height of that, okay? And then again, we're pushing this little contact to the dial surface here. And here is your reading. Okay? So make sure that you carefully watch the reading, yeah? As it balances with the height of that dial that we're trying to measure this little guy right here. Yeah, of course you can watch this again and again, so you kind of get an idea of how to adjust the 0, okay, with your pointer, and how to observe the turns. All right, it's really fast. So you got to do it again and again in order for you to be able to see these turns in both dials, the big dials and the small dial. Yeah, and then you will place the object of interest to get the height of that. Yeah, after gauging with the gauge block. So we're going to continue after the little videos. Yeah, we're going to bring back here. So after we replace this gauge with this dowel, right? And we have already counted how many turns it went as we bring that down, yeah, after removing the gauge, and we put this dowel in, and we still see this the pointer went down past the original 0. It went down all the way to 22 marks, all right? So this is 10 and 20, so it went down 22 marks, and that is, since each mark here is 0.001 inch, so you will get like 0.022 inch, okay? But it went 22 marks down. So therefore, you're going to have that measurement, okay, 0.022 inch. shorter, okay, than your gauge block, because when we measure the gauge block, it was at 0, yeah, and as soon as we swap it with this dial, it went down 22. So therefore, this, all right, height is 0.022 millimeter. Oh, sorry, this is in inch, so 0.022 inches shorter, okay, than this gauge block. Got it? So you know the exact, right, accurate height of this gauge block minus what you just read, which is 0.022, and that is going to be the height of this dial. Yeah. So now you understand how to use the dial gauge. You need the gauge block. We know the exact height of the gauge stack, yeah, because it is printed on the gauge blocks. So you're gonna add them up, and then you're gonna set 0, okay, off the top surface of your gauge. And then you're going to swap, yeah, your gauge block stack with the object of your interest to measure, okay, and then you're going to do the math, either subtract or add, okay. If it drops, then you subtract. If it rises on the other side of the 0, yeah, you're going to add it up. All right, add that measurement up to the sum of your gauge stack. Okay, so you get an idea of how to use this dial gauge. Make sure you will take the lecture, or you wouldn't be able to know how to do it in your lab. Okay, so I give you the lecture 24/7 access, so you won't miss it. If I lecture only one time in class and you don't listen, you know, and you're not gonna get it. But right now you have it all the time, so make sure you will take advantage of that. Yeah. Okay, then we're gonna come into the English dial gauge, which is your inch, okay? And of course, so we definitely need to know about the markings, yeah, on the dial face, and you have to know the meaning of the pointer, yeah, and you need to know of course, you need to know the markings and the pointer for each gauge, dial gauge type, okay? So now here, when you look at it, you have like a 0.001 inch, and then see another 0 all the way to 1 inch, okay, and then your little dial right here, okay, that goes like 0.1 inch, okay. So here the little tiny little things is a 0.001, and this is going to be 0.1, yeah, inch, and the whole thing can go from 0 all the way to 1 inch in total, yeah. Because this 0.1, if you go all the way to 0, that's altogether 10, yeah? So 0.1, if you add them up, all of it, for 10 times, you're going to get 1 inch, okay? So from here to here is telling you that we can be able to measure all the way from 0 to 1 inch. From here to here, you have a very, very big dial here. It's telling you each one of them is 0.001 inch, okay? Alright, here we will get into our inch, yeah, dial gauge, and this diagram you can be able to see very, very clearly, yeah, your big dial and your little dial. So here is your small pointer inside of a little dial, and I have already told you that's a 0.1 inch, okay, for each marking here, and you have to know the value of these markings. So that's a 0.1. And it has 10 of them, so you have 1 inch in total, yeah? So if this dial is going to move 3, yeah, 1, 2, 3, then you will have 3 turns, and that's going to be 0.3 inch, okay? You're going to have a 1 turn, 2 turn, and then 3 turn, because each one of them here is 0.001. See each mark right there. So it's showing you the graduation right here, you know, your discrimination. So that's a 0.001. So one round is going to give you 0.1, okay? Why? Is because there are 100, you know, marks on it. So 100 times 0.001 is going to give you 0.1 inch, which is equivalent to this little dial to 1, okay? That's going around 1 time, 2 times, 3 times. So in previous slides, right, in the early slides, I already show you it goes 1 turn, 2 turn, 3 turn, and then you can be able to rate it in your small dial going 1 turn, 2 turn, and then 3 turn, okay, your turn counter. So we call this, it counts the turn because each one of them is going to indicate the larger dial right here going 1/4, okay, round. So we know that for the larger dial marking, the smallest one is 0.001. So if, all right, this pointer moves about 15, okay, 15 marks. So 10, and then you go 15 marks, you know that it's moved like a 0.015 inch, okay? Yeah. The plunger means I call it contact, some people call it plunger. It's just a stamp in your contact, right? Right here. Because as you know, we're trying to measure the height, okay, height. So this going up and down is very important, and it's very sensitive. Again, the touch, all right, on the surface of the object that you're measuring. So therefore, every time this, okay, contact touches the surface, then you're gonna see, right, sensitive or dial pointer going around, yeah? Either it's gonna drop on this side or drop on this side. And this we call the negative side, and that we call the positive side, okay? And you have a gauge block stack, and you know the height, the exact height of the gauge block stack, because each block has a specific, height, which is your specification. So if you know the sum of that gauge stack, you can either subtract or add, okay, depends on the height of the object you are measuring, okay, by using this dial gauge, okay. That's how it works. So you gotta make sure that for each gauge type, okay, right here in this example we're in inch gauge, inch dial gauge, of course. Because you have to pay attention and know each gauge type that you're dealing with in your lab, and you gotta understand each mark, okay, for the larger dial, and also mark, okay, each mark in your smaller dial, okay. You gotta know each one of their values, and you have to know what they are, and you need to know how to use it to measure, the height of the object that you want to measure. Okay, this is another example but showing the same thing here for you, but a little bit different, because this one is going, see, 0.001 all the way to 1 inch, and of course you also have a turn counter right here, so the small dial turns in the opposite direction, meaning like it goes in a counterclockwise, and this one is going in the clockwise, okay. So of course, this turn is always opposite of the turn on the larger dial, So your small counter is going to count the revolutions of your larger pointer, and each, okay, revolution of your larger pointer is 0.1, okay, and we can be able to see it in the small dial here. So inch, so all of them add together is going to give you, so 0.1, 1.1, 0.2, 0.3, all the way to here, that is going to give you 1 inch, okay. And I've already showed you that. This is just a little bit different UK dial gauge from the previous example, but it's the same thing that we're trying to show you with different example. So here you have like a point, 001 for the small, but of course you can't be able to see it because it's a different type of dial gauge. So you can see only from here all the way to here, 1, so that's altogether 10. So you have a 0.01 because you're multiplying 0.001 times 10 is going to give you 0.01. That means they're going from here to there, So one round from here all the way to here, markings altogether 100 of them, So therefore, you have 0.1, because you multiply 100 times 0.001, it's going to give you one revolution on 0.1 inch, which is indicated by this little dial indicator right in here, little dial right in there. So when you carefully look at the numbers, you can be able to see it's going in different directions, yeah, positive and negative. So you can see 10 and 90 overlap here, because if you go this way, 10, 20, and then you will have 90 here and 100 right there. If you go this way, then you have 10, 20, 30, 40, and then go all the way, yeah, 90, and then you will have 100, okay, markings right here. See, this is a little bit difficult because it's showing bi-directional, yeah, not like this, the one that we just saw. This is only one direction. This is two directions. So you can read all the on the side or this side. Of course, inside here also give you the two directions, and that's the reason why you're seeing, see, 0.2 and then 0.7 overlap right there for you. Yeah, so either you go this way, okay, or you can also go that way. I think you're gonna struggle a little bit for the little dial. Let's just go in, okay, so 0, and then 0.1, 0.2, 0.3, 0.4, and then 0.5, 0.6, 0.7, 0.8, 0.9, okay, and then go back to 1. So instead of 1, you're actually going in order for us to make 10, okay, which is actually 1 inch, you have to go 2 revolutions on that, okay? This is how we read it. So make sure that you read in the way I just taught you how to do it. Okay, so you go like 0.1, 2, 3, 4, and 5, 6, 7, 8, 9, and 0. Yes, I went 2 revolutions. So now this is just showing you, okay, the measurement steps, how to do it. First, of course, we zero out by using the gauge block. Of course, we know the sum of the gauge block, and we zero out one end. Okay, so after you zero out and swap your object, you should be able to get either drop or add, okay, either on this side or this side. And we know that your big, okay, dial, the larger dial, is going to move clockwise, going in the positive direction, and which is also indicated by this little dial in the opposite direction, which is your counterclockwise, okay, direction. So that's what we are showing you this way, yeah. And of course, after you have zero out, you're going to have a part to be measured, yeah. So this is your example question is telling you, and then the dial gauge above is going to move clockwise from the 0 points, 0 position, okay. I call it point, but they call it position. So anyway, so the smaller dial is going to move hardly or at all, meaning the larger dial did not go all the way around, yeah. And then you're going to read the height measurement from the gauge relative to the origin position, and then you have to know what is the reading. So you already know, right, the gauge stack, and I have already told you, you know the exact measurement of the gauge stack. So therefore, after you swap your object, you can be able to either subtract or add, okay, depends on where your pointer is going. So in this example, let's take a look at here. So in our case, in this case, of course, you zero out the full marks, and you have 0.0 inch, because this is our 0 point. Your contact, okay, contact is on the surface of your gauge stack, and then you have to figure out how many marks the larger dial move. So the dial is going to move, let's say, like plus 21 marks after you swap your object, okay. So each mark is going to be 0.001 inch. So 21 times 0.001 inch is going to give you 0.021 inch, okay. So now we're going to add 0.0, that's our starting point with the gauge, and then we have 0.021 inch. So altogether you get plus 0.021 inch, okay. So we know that our part is larger than the stack of the gauge block because it is dropping on the positive side, okay. If your pointer is dropping on the negative side, then you would know that the height of the object that you're measuring is smaller than your gauge block, yeah. Do you remember in the earlier slides that I told you don't worry about it when we are talking about going in the negative direction or positive direction, and we use the terms like the items, smaller than our specification, and we can also measure the items larger than our specification in the earlier slides. And I told you don't worry about it because we're going to get into it in details right now. That is what you're seeing, okay. So here you can you can be able to measure the item larger than the stack of the gauge block, and this is our specification, okay, because it's going on to the positive side, about 21 markings, okay, on the side. So therefore you're adding 0.021 inches to your gauge height, okay. That means your object that you want to measure the height of it is larger than your specification, okay. Got it? So by using the dial, all right, indicator, you can be able to use either or, plus direction or negative direction, yeah. And then of course you always have, I think I should draw this for you. So we always have our gauge, okay, stack right here. So you know the height of this, okay? You definitely know the height of that, yeah? And then you're gonna swap it with what you want to measure. Okay, in our example is our cylinder, your dial, yeah? So this height can be either larger, yeah? If that's larger, your dial indicator markings will go to the positive side, okay? If your dial has a shorter, shorter height than your specification, because we call this gauge stack our spec, okay? Let's be easy. Spec here, okay. So then if your pointer falls to the negative, right, side, all you have to do is just minus, right, this reading from here. If your dial goes, your dial pointer goes to the positive side, all you have to do is add, all right, the value to this sum, okay? Because you definitely know the exact measurement of this because your gauge has values on each of the block, yeah. All you have to do is just sum it up. So you're gonna have a sum of this, yeah, and you can add it. You get the height of the larger items. You have the sum. Your pointer shown on the negative side. You're gonna minus what you read, okay, what you just read out of this sum, okay. So you're gonna have a shorter height or smaller item, yeah. And of course, this is example 1, and then we have 2, 3, and 4. So these are the exercises you have to do, okay, in class, of course. And I will be asking you to do it, yes. And if you haven't, make sure that you will practice that. I have already shown you what you have to do in class. It's example 1, 2, 3, 4, yes. And then, okay, so now let's get to part 4. Is reading the English dial, and this time without the turns counter, yeah. I tried to make it a little bit bigger so you can be able to see it. Okay, this is another one, which is your English gauge, and as you can see, there is no little dial inside, yeah. And when you look at it, it's a little bit difficult for you to be able to read, but that's 0.0005, okay? And you have 30 here, and then 5, and then go all the way, yes, to 0.225, okay? So let's take a look at this. And now in this diagram you can see a little bit better, yeah. So here 0.0005 and then 0.25 inches that we can be able to go, and we have no turns counter. So this is your tech log C1 English dial gauge, and you have smallest marking, okay. Here is going to be 0.0005 inch. So the total, yeah, the entire thing from here go all the way to one round is going to be 0.25 inches, yeah, because each marking here is 0.0005 inch, so there are altogether 100, okay, marks in one full rotation. So when you multiply, yeah, 0.0005 times 100, okay, so you're gonna get a 0.050 inch, okay. Okay, so your full rotation, okay, is a 0.051 revolution, right? But this dial gauge is capable, yeah, the capability it can go all the way to 0.25, so that's 5 revolutions. Yeah, it can go. So this is the same tag lock, right? The gauge. We have 0.0005 going all the way to 0.25 inches. It can read, okay? So one round is going to give you 0.05 inches because there are 100 markings, right? From 0 all the way back to 0 here. It can go two directions, which is negative and positive, yeah? So between these markings, and that's the smallest unit is going to be 0.0005, okay? So altogether, you have a 5, right? 5 revolutions is going to give you your range, which is your 0.25 inches, yeah? Because one round is on 0.05, yeah? So 5 rounds is going to give you 0.25. So we don't have a little dial here, to keep track of the revolution it went. So you have to manually count it. Okay, so that's the only thing. Of course, this dial is capable of going about 5 rounds. Yeah. So you gotta figure out how many revolutions the dial has made for your height that you're measuring, and then in which direction it's going, either this way or that way. Yeah. And then you're gonna multiply that revolution by 0.05. Yes. So you know like how many rounds it went, for your gauge block stack, and you swap it, to the object that you want to measure, and then do the same thing, either go to the negative or positive direction, and whether you're going to add, the markings on this side or subtract the markings on this side, after swapping the gauge block stack and the object you want to measure. Okay, all right. So that's what's basically telling you. Of course, when you read it, it's really difficult for you to be able to understand it, but when you do it, it's pretty easy. Yeah? And I talk a little bit fast because I'm quite used to these instruments, okay? For you, probably you might want to go little by little, okay? Anyway, so this is your another exercise. Your answers is given there for you, so you should be able to do it. Yeah, this is another exercise. We're gonna do it in class together. So anyway, I gave you the answers right here. Okay, so what I want you to do in the exercise is for you to read, okay? And of course, you've got to compare to the gauge block stack because that's where your accurate, specification is. So here, of course, you're not provided with the gauge block stack value, yeah? But in the lab, you know this value, yeah? Because you will be getting each specific block, so you can add them up, yeah? And of course, the part is larger, so therefore you're going to add this to the gauge block stack, in the lab. So you get the accurate measurement of the object of interest, yeah? And we do the same thing here. Of course, if you go to this side, it's positive. If you go to that side, it's going to be negative. Yeah, where your how your larger dial pointer, is going either clockwise or counterclockwise. Yeah. So this is how you do the math and do the logic. Yes. And of course, here in this slide, it's not given to you the final answer of the height of the dial that you'll be measuring, yeah? And that's, I have already taught you here in the lecture. So if you didn't attend the lecture or didn't do the lecture, then you're gonna have a little bit of struggle in the lab how to get the height of the object you're measuring, okay? Okay, so another type here is your metric dial gauge with a little turns counter right there, yeah? So when we look at this small markings here, we know that's going with a 0.01 millimeter, and we can go, yes, all the way to 1 millimeter. So because you have like the same thing, yeah, 100 markings for the entire rotations, and you have 0.01 times 100 is going to give you 1 millimeter in total. The small pointer is going to count you the revolutions of your larger pointer. So if it's go like the wind, revolution, it's going to give you, it's go, one revolution is 1 millimeter. So therefore, each of the small, a marking here in the little dial is going to give you 1 millimeter. So that's a 1, 2, 3, 4, 5, 6, so all the way to 10 millimeters. So these are the dial gauges made in Japan. Japan is very very famous for the accurate instruments. So they're also very expensive, but they're very good accuracies and precisions. Very meticulous. Japanese brain is very meticulous. Then here is a little bit better diagram because you can see it clearly. So here you can see 0.01 millimeter, and this is still your tag log, and going, you can see it's bidirectional, so you can go 10, 20, go 100 markings. Right there, it's going to give you 0.1. So each of this little marking here in this small dial is going to give you 1 millimeter, because you go from 0 all the way back to here, and that is 1 millimeter, because each marking is 0.01 times 100 is going to give you 1 millimeter here. So each revolution of your larger dial indicator is going to give you 1 marking, in your small dial here. So therefore, the small dial, each marking in this little dial is going to give you 1 millimeter rating, and we have 10 of them. So therefore, it's going to measure up to 10 millimeters. So that's the capability of this dial indicator. Of course, you can call this a dial gauge. It's the same thing. And this is a full instrument that you can see from top all the way to the contact. So tag log a little bit different, and still in our metric. The dial gauge and the smaller markings is going to give you 0.01 as usual millimeter, and 100 of course the times of that is going to give you 0.1 here. It's going to give you 0.01 times 100, and the whole thing is going to give you 1 millimeter. And this smaller one is going to give you 1, 2, 3, 4, so that's a 1 millimeter, 2 millimeter, 3, 4, 5, 6, 7, go all the way to 10. So that's all together, 10 millimeters. So since graduation from here to here, or discrimination is, you can see the a big, that's the halfway through from 40 to 50. So from here to here is going to give you 0.1 millimeter, because from here to here, the one step is going to give you 0.01 times, 10 of them is going to give you 0.1. So that's what you can be able to see, tiny little one, and that step is 0.01. If you go from here to here, there are 10 of them, so therefore, this times 10 will give you 0.1, this times 100, because the entire revolution, one revolution has 100 markings, and that's going to give you 1 millimeter. And little dial is going to count the revolution of the larger dial, so each one of them is 1 millimeter. We can do 10 of them, so 10 countings here. So this is called the turns counter. 1 turn, 2 turn, 3 turn, 4 turn. What kind of a turn? The turn of the larger dial. And we can the instrument is capable of counting all the way to 10 millimeters. Okay. Now this is for you to do in class. So we have 3 separate exercise for this lecture that you have to do in class. We have only 1 hour 45 minutes. So therefore you have to take the lecture at home. So when you come to class, you can be able to do that in class. So if you have questions, you can be able to ask me. How to do it. So it's the same thing. Yes. So you have a larger dial, smaller dial. You're going to gauge it for your gauge block stack. and then count all of the rotation, how it's going, either to the positive or negative. And you're going to swap your object of interest, okay? And then you're going to count from the zero, whether your pawn is going to the positive or going to the negative, clockwise or counterclockwise, right? Count that markings. So you're going to either add or subtract, yeah? And you know the sum of your gauge of block stack accurate specification, because the values are written in your gauge block, yeah? So therefore you have to just sum it up and then either add or subtract the reading after you swap your object, yeah, with your gauge block stack. Okay, so here in this example, so your each marking is 1 millimeter, so it went counterclockwise, negative directions of 4 revolutions, okay? So therefore you get minus 4 millimeter. And the larger dial, okay, has moved counterclockwise 59 marks after swapping the object, okay? And so you get a minus 0.59 millimeter, okay? So it means that your part is actually smaller than the stack of the gauge block, okay? So how small it is smaller, 4.59 millimeters smaller, okay? Okay, so this another example that you have to do in class. So here the same thing, we have a larger dial and then the small dial, and we already zero out with the gauge block stack, and then we swap it and your object is in there, and then you start looking at the larger dial. So it moved, right? It moved to the positive in this example. And when you check your little dial, you saw that it moved about 2, okay, turns. So that means actually moving 5 turns, yeah, because it said starting at 2 and then reaching this 7. So it means that it moves 5 turns, okay? So therefore you get 5 marks on the smaller, yeah? And then each mark on the small dial is 1 millimeter, so times 5 will give you plus positive, going to the positive direction, 5 millimeters. All right, and you also have a 6 marks on the larger dial, yeah? So therefore you add that, and it's going to give you each of the larger okay dial marking is 0.01, so times 6 is going to give you 0.06, yes? So then you're going to add your 5 millimeter and 0.06 millimeter, so you're going to get 5.06 millimeter, and which is larger than your stack of your gauge block. So this is a little bit, this 2 example is a little bit different from the first, okay, 2 exercises that I want you to do. So the difference is if you pay attention here, yeah? So right here is where your gauge stack is being zeroed out, okay? So this is the first revolution that you're getting. So I'm gonna draw that out for you here so you can be able to understand, yeah? So this is where we're measuring the gauge block. And then this is where we're measuring the part, okay? And this is you're either adding or subtracting, okay? This portion with the first measurement, okay? So this is where we're zeroing out the gauge block. So we are counting all the revolution. The second one is after you swap the object, and you will either get a plus or minus direction. You know, here in our case, we get a minus direction. So then you are going to subtract that from this, okay? So right now we're reading with the direction, so you don't really have to do the manual, right? Manual calculation. All we do is because we're reading directional, okay, calculation. So this is minus 4 millimeter, and then you have minus 0.59 millimeter. So that's the same direction going to the negative, yeah? So therefore we do 4.59 millimeter, smaller than the stack of your gauge block. So the difference between the former examples and here is that here we are measuring the part directly, okay? So you have counting the revolutions, okay, or turns, and then after counting the turns, you're gonna have to count, okay, the extra markings, okay, after the full revolutions. So when you bring it down, when we're practicing with the former example, you're doing with the gauge block stack, and then you swap it, right? When you do the direct measurement, okay. So yeah, just pay attention when you measure, okay, when you measure your gauge block stack, because again your height, your part height is measured relative to that, okay, and gauge block stack. So these are the confusion point for you to pay attention, okay. Of course, writing here is a little bit confusing to you sometimes because you have issue understanding the directions, okay. And don't worry too much about it. Just do what you have to do, okay. Is your gauge block, measure it, revolutions, swap it, get the object, measure that, add or subtract from the gauge stack, okay. So this is the way you should be going instead of writing this way, because this one doesn't really tells you where the gauge block is. Are you measuring the gauge block, or are you measuring the part, or here in this way of writing? And most of the textbook like that, I don't like it. But it's kind of like cheating the information in there. But don't worry about it. Yeah, when you do in the lab, you're gonna clearly understand how you will be measuring the gauge block stack and then your object of interest. Okay, I'm gonna go ahead and stop right here.